Hey, good evening, guys. This is Guru B tonight. So I just wanted to solve this problem together, or you can watch me do it. But I feel that a lot of network engineers, a lot of computers guys, especially those that are doing networking, don't really know how to subnet and how really to deal with IP addresses and subnetting. So tonight we have just one side of the many challenges or the many problems that you might have with IP and subnetting. So this is one question tonight. So what valid host range is the IP address 172.248.47/27 a part of? You don't really have idea to this. You might be like wondering, how am I gonna do this? So there are many ways. I've seen a lot of guys getting the solution in many forms, but tonight we are just going to do it. I think this is the best way, and trust me, no matter where you go, you can compare this trick to any other trick and let's see which one works faster. Because if you're writing a CCNA test, you require less time to solve problems. Okay, so let's go. So now what are we going to do here tonight? The first thing we're going to find is we're going to find the borrowed bit, because now they give us /27. So what I'm advising here tonight is for us to identify the borrowed bit from this guy. So the borrowed bit from 27, and the default is 32, because we are dealing with 4 tag and group of 8 bits. So the borrowed bit is what we're gonna get if we subtract this 27 from 32. Okay, so if we do that by saying 27 32 minus 27, because I don't want negative to go across, it's gonna be equal to 5, right? So we are going to raise the formula to find the block size, or the host bit, is 2 raised to the number of host bit, which we have 5. This is going to give us the sum of 32. Yeah, it's going to give us the sum of 32. So with this, we are just simple. Okay, so now our next step, we are going to put this 27 into the decimal form. And how we're going to do that? This 27, like I said, we're gonna, so the easier way to remember this, I don't want to make things hard, is for you to write 27 as in 1 27 times. What am I saying? So you check 27 as in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay? So we are going to put dot between every 8 count. So it's 1, 2, 3, 4, 5, 6, 7, 8. So we are going to put a dot right here. So we identifying the bit. It's 1, 2, 3, 4, 5, 6, 7, 8. We're going to put a dot here. And we're going to check 1, 2, 3, 4, 5, 6, 7, 8. So we're going to put a dot here. And we have 1, 2, 3. So we're going to make this 8-bit, but offing all the guys. So all the numbers here are off. So this is the binary form for this /27. So this is the binary form for this. So whenever you are asked to write the binary number for 27, this is how it's going to be like. Okay, so from this we are going to find our valid host range. With this formula we are going to find our broadcast, we're going to find our network, we're going to find our first valid host range. So let's move on. Sorry, my hand is shaking tonight. I'm using another hand. So now this, from what we have, we are going to draw a line right here. Okay, so remember all of this are on network. Bit, and this is the host. Okay, what I draw the line is the host. So from here we are going to check, or other way from here. So this is 128, this is 64, and this is 32. So we write our 32 here as in the same 32 that we have here already. So we write our 32 here. Why are we writing it here? Because we checked 27 as in once 27 times, and the last digit is what we are going to focus on, and the last one is this one is a 32. So the next thing we're going to do, we're going to add all of these bits that are off. So this is 1, this is 2, this is 4, this is 8, and this is 16. So if we add all of them, we are going to get 31. Hope you're getting the concept. You see that? So we got 32 from this. So to prove that this, our last bit is 32, is we write down 27 as in 1 27 times. So the last one is what we're going to focus on, and the last one in decimum is 32. Okay, so, and we definitely have to equate or balance this as an 8-bit values. So represent, we fill out the remaining 5 values with 0, since they are off, and we add out of the values that are attributed to these zeros. It gave us 31, which are 1, 2, 4, 8, and 16. Okay, it gave us 31, and now we have 32 here. And the question is saying, what valid host range is the IP is part of? So now our next step is this. Very easy. So now we count. I'll start incrementing by 32, right? Why? So write down our 32, okay, which is the value we have here. We write down our 32, okay. So now this would be our network bit, or our network value. You understand? So this 32 is going to be our network value. This guy going to represent the network, And now we are going to add, to find the broadcast, just add this 31 to this 32, and the value is going to give you 31 is going to be 63. Okay, so 63 is our broadcast. Hope you're getting things right tonight. This is our broadcast. So we added 31 plus 32. We first put down this 32, and we add this 31 to this 32 is going to give us 63. So now our valid host range in this IP is going to be, because we're going to reserve is -2, so we're going to reserve one for the broadcast and one for the network. So we're going to start from 33. So now we are finding our valid host range. So it's going to be from 33 to 62. Okay, we cannot use 32, we cannot use 63, because our network bit address will be 32 and our broadcast address is going to be 63. So we cannot use them. We cannot assign them to any computer on our network. So the IPs that we are going to assign to our devices on the networks is going to be from 33 to 62. Okay, so we're going to do this until we can reach this. Oh, I guess we have already seen this. So definitely we're going to stop here. Okay, because 63 is bigger than 47. All right, so we're going to have a larger number here. We're going to keep going, but however we can still go. But this is the answer that we want tonight. Our valid host range, so it's not gonna be, if you are doing a range, it's gonna be a 172, the 24, 24, sorry mathematician, the 248, the 33 to or true 172, the 24, the 248, the 62. So this is going to be our valid host range and the IP address that we have, and this is going to be our broadcast and our network. This is our first range. Okay, so this is all we have tonight. This is just a simple answer that you can have for today. If you don't understand anything, you can send an email to otblog@gmail.com, or you can highlight at me. Let me write my email here so you see that. It's O, small o, right? It's otblog@gmail.com. Okay, so it's otploh@gmail.com. So you can send me an email to that if you need more videos or if you need more clarity on this question tonight. So this is just all we can give you tonight. So you find out that with this simple address or with this simple formula, we are now able to find our network and our broadcast, and we are able to find our valid host range. So we are not just find our valid host range, but we have identified our block size, we have identified our host bit, and we identify a lot of things here. So with this one solution, of this one formula, you can find a lot of answers that you can save. Maybe if you ask another question again, and you can just choose an answer. Maybe you say, what is our network? And you're going to say 32 right away. So it's easier. There's another way that you can find a network, but I think that is long because I tried that before. But however, if you don't understand this, you can send me an email to this, and I'm going to better explain it to you. Okay, good guys. See you next time. We're going to be having some lecture session. And want you to like this video, and I'm gonna do more. Okay, bye bye. This is Guru B. Bye.